This is the context that they are setting. Software systems are integral part of our daily life. They're actually talking about software systems and the effects of systems that are not being tested. Software that does not correctly work correctly can lead to many problems, including loss of money, time, or business reputation, and in extreme cases, even injury or death. Just a quick question, please. Who here has already encountered a system, or who here can give an example of a system that, when it's not working correctly, it can lead to an injury or to death? Feel free. Anyone can just open his mic and talk.
Talking about any case scenario like
Ye-
that is malfunction,
yes, yes.
even drugs, right? Drugs that is not administered properly.
Drugs. I'm talking about softwares.
Oh, okay.
So I will help you. Let's say we have a context. I don't know if that exists in Cameroon. Is very manual. A context where uh you have already a system in a hospital that does the prescription automatically into software. Let's say um the doctor has to input some data, and the system is giving out some prescription. Well, this case is really abstract. It's just for you to think. So, given that the inputted the system normally does, the doctor inputs the data and the system prescribes drugs according to the data. Like, let me say symptoms. You enter your symptoms and it prescribes you drugs. So um at the level of the doctor, everything was fine. He entered the correct symptoms and all the like. But at the level of the system, the matching was not done right. So that wasn't tested. And this is a case where the system can do false prescription and give something maybe to a pregnant woman that she should not take. It can cause severe injury into her health or even death. That's the extreme case. So this is a very abstract example, but I think with this already you can already see how testing is really important, right?
Yeah.
So that said, is anyone here capable of giving an example of a software? You can even give one you encountered that if not well tested, it can lead to death. No, no, no. Let me just proceed. So, software testing is a set of activities to discover defects and evaluate the quality of software work products. These work products, when being tested, please, as I'm going, if you are stuck somewhere, just ask your question. These work products, when being tested, are known as test subjects. Yes. A common misconception about testing is that it only consists of executing tests. So, this is very important.
Excuse me. Did we launch the recording?
Yeah, I'm sure because it's been shared on YouTube. Yeah.
Yeah, I'm recording.
So, a common misconception about testing is that it only consists of executing tests, running the software, and checking the test result. Yeah, this is very true. This is a mistake so many people do or think about testing. They think that testing is only about um executing tests, which is false. They are saying here that it also includes other activities that must be aligned with the software development life cycle. I guess everyone here knows about the software development life cycle. So SDLC, for people that don't know, let me share it. Let me share my screen completely even. Mm, I guess you guys can see. Hello. Can someone confirm if you can see my screen, please?
But
Oh my god.
Yes, we can see your screen.
Okay. Thank you very much for confirming. So this is the software development life cycle: planning, analysis, design, implementation, testing and integration, maintenance. So this is a kind of waterfall software development life cycle where testing is at the fixed position, but in interactive life cycles, testing comes at every step. In planning, you test; during analysis, you test; during design, you test; during implementation, you test; during maintenance, you test you. So this is the modern way of developing. So another misconception they are talking about is that testing focus entirely on verifying the test object, while testing involves verification. That's checking whether the system meets specified requirements, which also involves validation, checking whether the system meets users or stakeholder needs. This operational this this is the operational part, and that's another misconception about testing. So testing can be dynamic or static. Dynamic testing involves executing of the software, like let me say you actually run the app and all the like. That's dynamic testing. um, um, Static testing means reviewing is all about reviews. As been said here, it's all about reviews. Like maybe they give you the specification of a document and they tell you, okay, please can you review this and check if there are no loopholes in developing a software and all the like. You're like, okay, I'm reviewing, and when you find a loophole, like what you're actually doing is doing static testing. Because static testing, you in static testing that you are not running or launching any application. You are doing it when the application is at rest or is not even existing. So that static testing does not need a built application to be done. So as they say here, testing is not only a technical activity. You also need to be properly planned, managed, estimated, monitored, and controlled. So here, there, as you guys see, software development life cycle. There's also software testing life cycle. So this is the life cycle of testing a software. So you analyze the requirement, you plan the test, you develop the test case, you set you set up the environment, you execute the test, and you close the test. So
a
you
question. Okay.
yes,
What is, can you give me the example of test case? What is test case?
okay. Mm, I explain best with visuals here. So So let me just copy this and send in the group, and you will see the difference. Now I will be explaining. Who asked the question, please?
Birol.
Huh?
Birol.
Come again.
Birel.
Cyril, okay. I cannot see her at in the group. Well, I'll just send it. So here they say a test case is a set of action executed to verify a particular feature or functionality. Let's go with what the syllabus says. Test case.
This is
So they did not define it here.
yes.
A set of action executed to verify a particular feature or functionality. So let's say, right, you have a login. Let me explain with an example. You have a login screen, and you are required to test the login screen. Your test case will be to this is how you formulate your test case. As a user, I should be able to um enter my username, or you can formulate it like this: verify that a user can enter his username into the field. That's a test case, and that particular statement is clear about the action you need to do in a system to verify that the functionality actually works. So do you understand that as a test case?
Yes, yes.
Yeah. So in my company, that's how companies set test cases, like their teams. But in my company, we um we do not stop at that point. We go the extra mile by saying that a test case has to have a test step. Let me open this. This is very confidential. No, actually, let me say quality plus. If this was not shared on YouTube, I would have opened it. But company project is really confidential. So I'm really sorry. Quality plus. Quality plus test case. Images. There is none here. Hmm, where can I get it? A minute, let me get my phone. I think I want to share something like that to a friend. So I did not still get it. But what I wanted to say is, in our company, we go the extra mile by saying that a test case should not just be that statement, because some other companies just stop at that statement. What we do is we will say the test case should have the test step, the the expected result, and the actual result. So you have the test step, the expected result, the actual result, and the the attachment So that's what we have as test case. So you can have a test case that has so many test steps, and a test case can have a precondition. And aligning it like that, you are actually how can I say, you are you actually find it easy to report bugs, because when reporting a bug, you have to enter the same information, that's the expected result, actual result. So I hope that's clear about this case.
Mm-hmm.
Okay, so let's get back to what we're saying. And where did we stop? Yeah, we were here. So they say tester use tools. Yes, this is true. Tester use tools, but it's important to remember that testing is largely and intellectually is that testing is largely an intellectual activity, requiring the tester to have specialized knowledge, use analytical skills. If people were here during live session, I used to do about QA. I was always mentioning about having analytical skills and critical thinking as a QA. So here they say you should have, as a tester, you should have specialized knowledge, and the specialized knowledge here is what you're actually getting right now. You should use analytical skills. You should be able to actually analyze a set of activities that actually happen in front of you and say, okay, this is right and this is wrong. You also have to apply critical thinking and apply systems thinking. I would say system thinking comes with time, because someone that does not have experience into systems cannot really cannot really think like the system. So this comes with time. So the ISO IC I3E 29119/1-1 standard provide further information about software testing concept. So these are important information you need to check for your own personal knowledge or growth. Oh, I highlighted this instead of copying. So I was saying that these are information you need to really check out for your personal growth. It's not part of the syllabus, but you really need to check this out. It's actually free. So let me put my email, billing address. Do I need to fill all this information? Well, I will do this later, but I'm just saying that you need to read this out, in order to increase your knowledge about testing. So we are going to test objective. What are the test objective? The first test objective you have is evaluating work products such as who here knows what a work product is? Because we have been talking about work product. I don't know if everyone is getting it. Hello. Well, no one is with me. Let me just proceed. So evaluating work products such as requirement, user stories, design, and code. Um, Causing failure and finding defects. I don't know if you also attended my live once, but I was saying that um they when testing, you should first of all try to make your test to fail, then and see why it's failing. That's this actually what they say. You are causing failures. Now you are and finding defects. Ensure require coverage of a test object, reduce the risk of level of inadequate software quality, verify whether specified requirements have been fulfilled, verify that a test object complies with contractual, legal, and regulatory requirements. This is mostly about compliance. So that's why um you should know what you are testing and all the rules and regulations that govern the system in which you are. You should also know about basic cyber security, but this is not a this is not something that you it's not a must have before starting, if I want to say it like that. Providing information to stakeholders to allow them to make informed decision. This after your test closure, you have to submit the report, say how the test worked and all the like. Build confidence in the quality of the test object. Validate it, whether the test object is complete and works as expected by the stakeholder. So these are the objectives of testing. This is why you are testing. Like this is what you want to achieve when testing. So this is very important as to this is very important to know as a QA, because during even interviews, this is what you have to show out there to say that okay, you need to hire me because I am able to evaluate your work products and cause failures into it, then find the issues inside your system. I'm able to provide test coverage of your system. That's basically testing a whole system. Yeah, I'm able to reduce risk um, of inadequate software quality. This like when the quality of a software is actually low, you can reduce the risk of having that low quality into system. So these are really the things you need to get to be able to share out there, potentially to recruiters, and tell them that yes, I can do this for you. So really mark this, really get this, because this is very important. So test objective can vary depending upon the context. I've always said that testing is not just normal, but you have to be in a certain context. So your objective can vary, and which includes the work products being tested, the test level risks, the software development life cycle being followed. I said here that there are so many software development life cycles, so your test objective can also vary according to that, and it's not only the test objective but how you're actually carrying out the test, and factors related to the business context, e.g. corporate structure, competitive consideration, time to market. So I also said here that you need to know in which environment you are to adapt your testing to that environment. So testing and debugging are separate activities. Testing can trigger failure that are caused by defects in a software or directly find defects in a test object. So testing has to do with dynamic testing and static testing. So to trigger a failure into a software, that's dynamic testing, because you are actually launching the app. Whereas finding defect into a test object is static testing, because here you are, the test object here is maybe the user story or the documentation. That's what you're actually doing. You are going through it to know if there are any loopholes into the user stories. In my own company, they call it refinement sessions. You have refinement session before actually building the expected outcome. So when dynamic testing triggers a failure, debugging is concerned with finding the cause of the failure, analyzing these causes and eliminating them. The typical debugging process in the case involves reproducing the failure, diagnosis, and fixing the defect. So you first have to reproduce the failure, because um, if you cannot reproduce a bug, then it's not a bug. You need to find the bug, like finding the bug, like the bug is already there, you're already reproducing it. So what they are trying to say here is that you need to find the root cause of the issue and fix it, because only reproducing it cannot fix it. Subsequent confirmation testing checks whether the fix resolve the problem. So after every fix, you this they are trying to say here that after every fix you are still testing. Preferably, confirmation testing is done by the same person who performed the initial test. So here they're trying to say that anyone that reported a bug, preferably he should be the one that does the testing to confirm that okay, it's no more reproducing. Subsequent regression testing can also be performed to check whether the fix are causing failures in other parts of the test object. So who here knows about regression testing? Daniel, do you know about regression testing? I'm still alone. Well, let's just continue. I'll just proceed because it seems we all know what we are doing here. Come again.
That regression testing is when you test a if a change can affect other components.
No, regression testing is testing uh, breaking another component, because there's a difference between I want to get value from what you are saying. I just want to show the value. Regression testing versus smoke testing. Yes, that's the term I'm looking for. So there's a difference between these. Let me get the image. So let me copy this and send in the group. So ensure that the critical functionality of the application are working fine after new changes. The new changes here can be fixing the bug. Ensure that the changes does not break existing functionality. So there's a difference between regression testing and smoke testing. In regression testing, after maybe a bug, you need to test the whole system. I'm saying the whole system, like run every single test case to ensure that nothing is being broken after fixing an issue, because sometimes you encounter issues where you fix this is no more working, you fix this is other thing is no more working. So that's why regression test is really important. So you should really mark that difference, the difference between regression testing and smooth testing. So you can do further research about that. Where did I stop? When starting testing identify a defect, debugging is concerned with removing it. So there is no need for reproduction or diagnosis, since static test directly finds defects and cannot cause failures. So here they're trying to say that uh, uh, defects defects are actually the issues found at the level of static testing, and debugging here is actually removing the defect found. So here there is no need to reproduce the issue here, because when you find maybe that there is a typo somewhere, you don't need to reproduce the step to find a typo, because it's obvious that there's a typo. So that's what they are trying to say here. And static testing directly finds the defects and it cannot cause any failure. Failure here is something that makes the system not to work properly as it is expected. So why is testing necessary? Testing is a form of quality control, and it helps in achieving the agreed upon test objective within the set scope, time, quality, and budget constraint. Testing contribution to success should not be restricted to the test team activities. So here they're trying to say that the success the success of the software or the product, that's the quality of the product, should not be restricted to the test team activities only. Like we used to say that, okay, if a product is not of quality, you are not to accuse the test team, because they are not the sole responsible of the quality into the application. This said, we should know that testing is not only for QA. There are also developers that test. How do developer test? Developer most likely write unit tests. In test driven development, they write unit tests to test unit blocks of the system. So here it it clearly shows that the quality of a system is not restricted only to the test team. So that's what they are saying. Any stakeholder can use their testing skills to bring the project closer to success. Test component, system, and associated work product help to identify defects into the software. So, taking the example of developer writing unit tests, any other stakeholder, product owners, scrum master, and all the like, designers, they most likely carry out static testing activities, but they don't know it's actually called a static test. So, testing contribution to success. Testing provide a effective means of detecting defects. These defects can be removed. So testing indirectly contributes to higher quality test objects. Testing provides a means of directly evaluating the quality of a test object at various phases in the LDLC. These measures are used as part of a larger project management activity, contributing to decision to move to the next phase of the SDLC, such as the release decision. Testing provides users with indirect representation on the development project. Testers ensure that their understanding of user needs are considered throughout the development lifecycle. The alternative is to involve a representative set of users as part of the development project, which is not usually possible due to high cost and lack of availability of suitable users. So this is basically literature. If you are not understanding something, you can just call me out to explain. Testing may also be required to meet contractual or legal requirements or to comply with regulatory standards. I explained this line here previously, or if you did not get, you can call me out to re-explain. Testing and quality assurance. Why people often use the term testing and quality assurance interchangeably. Testing and quality assurance are not the same. Get this. Testing and quality assurance are not the same. I am not different. I also make this error by interchangeably using testing and quality assurance, but we should really get that they are not the same. Testing is a product oriented corrective approach that focuses on those activities supporting the achievement of appropriate level of quality. Testing is a major form of quality control, while others include formal methods, model checking and proof of correctness, simulation and prototyping. QA is process oriented, preventive approach that focuses on the implementation and improvement of the processes. It works on the basis that if a good process is followed correctly, then it will generate a good product. QA applies to both the development and the testing process, and this responsibility of everyone on a project. So quality assurance is the responsibility of everyone in the project. That's what I mentioned below, above. That's what I'm trying to say. Test results are used by QA and testing. In testing, so this said, right, um is anyone here able to tell me, is testing quality assurance or quality assurance is testing? Can someone just say it and why he's for the fact that testing is quality assurance or quality assurance is testing? Hello, no one. So let me proceed. Errors, defects, failures, and root causes. I've explained this up, but I will just read to know if someone did not understand something. Human beings make errors. This is the context, which produce defects that are faults, bug, which in turn may result into failure. So the error here is the mistake a human being makes in the in the in the app, and this error made by the human being produces a defect. So it can be either a defect in the case of static testing, or for a fault or a bug in the case of dynamic testing. So which in turn may result in failure. So with this said, can everyone here just draw the life cycle of a bug? You guys can just quickly draw it on papers and send in the group the life cycle of a bug. Can you do that?
How come the life cycle of the book?
I just explained this. So human beings make errors which produce defects, which in turn may result into failure. So this is basically a life cycle if you get this right, Daniel. So it lives from an error to a defect or a failure or a bug, and in turn it gets to a failure. So it's in three step: error to defect, then
This term,
defects. Come again.
yeah, this term, failure, bug.
Come again.
I think this term, defect,
You're
failure,
really right.
fall, bug, that is not the same thing.
Yes, defects and bug are not the same thing. That's what you're trying to say.
Yes, I see. That's I think that uh, defect, uh, defect, bug, failure are the same thing.
Yes, they are. No. Defect, defect and bug are not the same thing, but they're on the same stage or the same level when it comes to a life cycle. Now,
What is
failure.
the okay? What is the difference between defect and bug and failure? What is
The difference between defect, bug, and failure.
yes?
A defect um is that which how can I say? A defect happens at the level of static testing, and a bug happens at the level of dynamic testing. I explained up that static testing is static testing is actually verifying work products to make sure that they meet they are of quality. The work product here can be the product documentation, the user story, um, the the design of the application. So when when you actually carry out static testing, that's reviewing these work products, any issue you feels there or any issue encountered is a defect. Are you getting?
Any use you feel in documentation is defect, right?
Yes. So now any issue encountered when running a program or a software is a bug. Like when you actually launch an application, it's running at the level of the background. So if you encounter any issue there, it's a bug. Now, are you getting? Are you
So
okay
Yes.
a
with that?
bug is any issue, or it's
Come
not a
again.
specific kind of issue. Is a bug any kind of issue, or is it a specific kind of issue?
A bug is any kind of issue that happens when the software is actually being launched or run, whereas a defect is any kind of issue that happens when the software is not being run. For an issue to happen when the software is not being run, it means the issue actually either happened during a code review, it either happened during in a documentation, like I said, a typo, it either happened in a user story, or it either happened in the design of the application.
Okay, I see. So a defect is not a major issue.
Well, it's a major issue because you should, this is the error we all make. You should never say a defect is not a major issue because a defect a
I mean
defect
by
happens.
I
A
mean by
defect
major issue like it will not affect the software.
It will because a defect happens at the early stage of development. So if there is an issue at the early stage of development, the software will be affected after its development,
So
and it
that
will be
means
more costly to fix that.
so probably I did not get well the defect.
Should I explain again?
Yeah, please.
So let me explain maybe with an example. That's why I like explaining examples. So you want to build let me say food delivery app, right?
Mm-hmm.
What's the first thing you would do?
If I want to view a food delivery app,
Yes.
I'm gonna enter in the application, log in the
No, I'm saying
application.
if you want to build,
Oh, to build. Okay.
yes.
Mhm.
The food delivery app. I mean, I don't understand. Like, after the developer finished writing the code or what?
No, if you want to actually code a food
Oh, code.
delivery app, yeah.
Oh, okay. Honestly, I don't know. I don't know how the developer do. So probably they have a sample of something of application that they take and then adjust it. I don't know.
How to plan. Is it?
Okay, you have to plan. Okay. So you most likely document the plan, right?
Ah, okay, okay, okay.
No,
Yeah.
I'm just asking a question. You most likely document the plan, right?
Yes.
Yes.
Okay, let's say that after documenting the plan and you want to execute the steps that you said that you would do and the specific at the specific time, and it happens that uh you actually made an error during the planning. So the static testing here that was not being done is to verify that okay, the plan that was made is actually what is needed to build the app. So you do not really test, or you do not really check, or you do not really cross check that this checking or this cross checking is the static testing. So you do not do that static testing, and
Okay.
it happened that your plan is faulty and you start working with a faulty plan. So at the point where you say okay, um at this point I will just start by designing the application without doing research, and you design the application as you think, and you end up building an app that is something that you saw as a problem in your head, but it's not an actual problem in the society. That's a big defect. That's a big defect that has happened when the app is already ready, because the app does not solve the society's problem. Like, you don't need to launch the app to know that it's a defect, because it does not solve. It's like you go to, I don't know which example to take. I don't know which example to take. Let me say, I don't really know which example to take, but you do not plan right and you build something that does not really help, just because you do not review your plan. So you can see the impact of that defect that was ignored at the level of planning, right?
Okay.
Yeah, okay, it's just kind of I'm not understanding still.
I mean, it's okay.
No, it's not okay. If you're not understanding, you should say you're not understanding so we explain it right.
I mean, I'm gonna make some little more research about it. Probably. I
Okay,
don't.
if you say so and you will do so, then it's fine. Let me proceed. Anyone here still has an issue with defect and bug?
Yes, the next step, although I understand why you explained, but the next step was failure. What is the difference also with failure? Failure, yes.
So a failure is actually um, a system is not working as intended. So that's the result of a bug or a defect. The result of a bug or a defect is that the system is not working as intended. Like, let me say the app we previously talked about that was designed without doing research or without doing market research. If the app is not useful, that's a failure because it's not fulfilling the purpose for which it was made, because people are not actually using it, and that was an issue since the planning stage, since the design stage. That actually skipped the market research or the research phase. So that's the cause. The cause is a failure. The end the end of it is failure.
Okay. Yeah.
So let me just proceed if everyone is understanding. Humans make errors from various reasons, such as time pressure, complexity, work products, process, infrastructure, or interactions, or simply because they are tired of or lack adequate training. Defects can be found in documentation. So this is the defect that I actually explained. Defect can be found in documentation such as requirement specification, test script, in source code, sup- or or in a supporting work product such as a build life. Defects in work products earlier in the SDLC, if undetected, often lead to defective work products later in the life cycle. If a defect in code is executed, the system may fail to do what it should do, or do something it shouldn't, causing a failure. Some defect will always result in a failure if executed, while others will only result in a failure in specific circumstances, or some may never result in a failure. So, Daniel, is this okay with you? Are you better understanding with this explanation?
Yes, yes. I read it already, so that's why I was like, when you were trying, I said, okay, I was reading.
Okay. So, errors and defects are not the only cause of failures. Failures can also be caused by environmental conditions such as when radiation or electromagnetic field cause defects in firmware. A root cause is a fundamental reason for the concurrence of a problem, e.g., a situation that leads to an error. Root cause are identified through root cause analysis, which is typically performed when a failure occurs or a defect is identified. It is believed that further similar failures or defects can be prevented or their frequency reduced by addressing the root cause, such as by removing the E. The E here stands for the root cause. Is this too much? Do you still have a lot? I think we still have a lot for this chapter one. Mm, let me check. Oh, testing through SDLC. One, two, three, four, five, six. We still have 5 pages. Can we finish it in 30 minutes? Let's just see. So testing principles. A number of testing principles offering general guidelines applicable to all testing have been suggested over the years. This syllabus describes if 7 such principles. So, as you all know, testing has principles. The first principle is testing shows the presence, not the absence of defects. And it's not only defects, it's also bugs. you should really know that testing shows the presence, not the absence of defects. And as a QA or as a tester, you should always put that in mind and make people to understand that, most especially your stakeholders. It's not because after testing another bug was encountered that will mean that you do not actually test, or you do not test completely, or you do not test effectively. If you found defects or issues, let me say issues because issues is more general. If you found issues, then you accomplished what you were supposed to do as testing. So hidden issues that you cannot discover or you cannot actually find, you're not God, should not really make you feel bad. So testing can show that defects are present in a test object, but cannot prove that no defects. Testing reduces, let me check this reference. Let me check this reference. Mm, well, sounds like it's a reference like that. Not really important. Testing reduces the probability of defects remaining undiscovered in the test object, but if no defects are found, testing cannot prove the test object correctness. 2. Exhaustive testing is impossible. Testing everything is not feasible except in trivial cases. Rather than attempting to test exhaustively, test techniques, test case prioritization, and risk-based testing should be used to focus test efforts. So, in the case where you know that you cannot test everything, you should you should test exhaustively. That is, limit your testing. You should review your test techniques, prioritize your test case. This is the most important. Always prioritize your test case. Then do risk-based testing. All of these terms, you will discover them in the subsequent chapters. Early testing saves times and money. As we earlier explained here, if you start testing at the early stage, that is at the planning stage of the software development life cycle, you will save more time in testing and more money, because the issues encountered at early stages are more crucial, are more costly than the issues encountered at the late stages of development. So defects are removed early in the process. Defects that are removed early in the process will not cause subsequent defects in derived work products. The cost of quality will be reduced since fewer failures will occur later in the SDLC. To find defects early, both static and dynamic testing should be started as early as possible. Defects cluster together. A small number a small number of system components usually contain most of the defects undiscovered or are responsible for most of the operational failures. This phenomenon is an illustration of the Pareto principle. Predicted defect cluster and actual defect clusters observing during test or in operation are important input for risk-based testing. What are they trying to say here? A small number of system components usually contain most of the defects discovered. So here they're actually saying that a small number of a small number of system components. Okay, so here they're actually saying that uh, the component that usually contain most of the defects, like where you actually find the more defects, that's where the the operational failures are the most, like those are the components responsible for most of the operational failures. So tests wear out. If the same tests are repeated many times, they become increasingly if ineffective in detecting new defects. To overcome this effect, existing tests and test data may need to be modified and new tests may need to be written. However, in some cases, repeating the same test can be a beneficial outcome. So here they're trying to say that um, when the same test is being run over and over, the the system kind of gets used to it and actually overcomes it. So that's why there's always the need to review tests and um, write new tests or update the existing tests. So that's what it's been called test maintenance. And mostly what is being done is updating the test data here. Testing is context dependent. There is no single universally applicable approach to testing. Testing is done differently in different contexts. So I think this is the fourth time we are talking about context in testing. Testing is not a generalized something that is being done same everywhere. It's very different, and for that you should really be agile and adaptable to each and every environment in which you find yourself, because if you are in charge of testing there or you're in the testing team, it will not always be the same as your previous team. Absence of defects fallacy. It's a fallacy, a misconception to expect that a software verification will ensure the success of a system. Thoroughly testing all the specified requirements and fixing all the defects found could still produce a system that does not fulfill the user's needs and expectation, that doesn't help in achieving the customer business goal, and that is inferior compared to other competitive systems. So I think this is actually clear. If it's not clear, you can just stop me. Let me explain. Test activities, test where, and test rules. Once again, testing is context dependent, but at a high level, there are common sets of activities, of test activities, without which testing is less likely to achieve test objective. This set of test activity form a test process. The test process can be tailored to a given situation based on various factors. Which test activities are included in the test process, how they are implemented, and when they occur is normally decided as part of the test planning for specific situations. The following sessions describe the general aspects of the test process in terms of test activities and tasks, the impact of context, test where traceability between the test basis and test where, and testing rules. What am I saying here? So the following section describe the general aspect of the test process in terms of test activities. Yes. Tasks, impact of context, test where, traceability between the test basis and the test where, and testing. Who here knows what test where is? If you don't know, you can just say I don't know.
I don't know. I want the question. I don't know.
So test where here is what is actually being tested. Let me confirm. What is a test where?
What is mm,
Testware are actually the tools. Wow. Generally speaking, testware is a subset of software with special purpose that is for testing. Okay. So I was lying, you guys. So testware here are the stuff used for testing. That's actually, let's just say, the testing tools. So the testing tools are called the testware. I was sure that what is being tested is what is called testware. Wow. I need to update my knowledge. So test activities and tasks. A test process usually consists of the main groups of activities described below. Although many of these activities may appear to follow a logical sequence, they are often implemented iteratively or in parallel. These testing activities usually need to be tailored to the system and the project. Test planning consists of defining the test object and then selecting an approach that best achieves the objectives within the constraints imposed by overall context. Test planning is further explained in section 5.1, that's chapter 5. So test monitoring and test control, it is also explained in 5.3, but it's just a brief here. Involve the ongoing checking of all test activities and comparison of actual progress against the plan. Test control involves taking actions necessary to meet the test objectives. Test monitoring and test control are further explained. So test analysis too is also very well explained in 5.2. Includes analyzing the test basis to identify testable features associated to tested test condition are defined and prioritized, taking the rated risk and risk level into account. The test basis and the test objects are also evaluated to identify defects they may contain and to assess their testability. Test analysis is often supported by the use of test technique. Test analysis answer the question what to test. So you should really get this. Test analysis answers the question what to test in terms of measurable coverage criteria. Test design. So these are actually the test activities and tasks. So you plan, you monitor and control, you analyze, you design, you implement, execute, you complete. I'm not sure this the steps, the order, because how can you monitor and control when you've not yet executed? Well, let's just proceed. Test design includes elaborating the test condition into test cases and other test ways. This activity often involves the identification and coverage items, which serves as guide to specify the test case input. Test technique can be used to support this activity. Test design also include defining the test data requirement, designing the test environment, and identifying the necessary infrastructures and tools. Test implementation includes creating or acquiring the tests where necessary for test execution. Test cases can be organized into test procedures, which are often assembled into test suites. Manual and automated test scripts are created. Test procedures are prioritized and arranged within a test execution schedule for efficient test execution. The test environment is built and verified to be set up correctly. Test execution includes running the test in accordance with the test execution schedule. Test execution may be manual or automated. Test execution can take any form, including continuous testing or pair testing session. Actual test results are compared with expected results. The test results are logged Anomalies are analyzed to identify their likely cause. This analysis allows to report the anomalies based on the failures observed. Test completion usually occurs at the project milestones, release, or end of iteration. Test level completion for any unresolved defect, change request, or product backlog items created. Any test where that may be useful in the future is identified and achieved, archived, or handed over to the appropriate team. Test environment is shut down to an agreed state. Test activities are analyzed to identify lessons learned and improvement for future iterations, releases, or projects. A test completion report is created and communicated to the stakeholders. Test process in context. Testing is not performed in isolation. Test activities are an integral part of the development process carried out within an organization. Testing is also funded by stakeholders and its final goal is to help fulfill the stakeholders' business needs. Therefore, the way the testing is carried out will depend on a number of contextual factors, including stakeholders that embodies the needs, expectations, requirement, and willingness to cooperate. Team members that should have the skills, the knowledge, the level of experience, the availability, and the training needs. Business domain. Here we have the criticality of the test object, identify risks, market needs, specific legal regulations. Technical factors, type of software, product architecture, technology use, and project constraint. You have the scope, time, budget, and resources. So we also have organizational factors. We are still on the factors, the contextual factors on which the testing will depend on. So we have the organizational factors, organizational structure, existing policies, practice use, software development life cycle. Is your is your team agile? Is your team waterfall? Engineering practices, development methods, tools, the availability of tools, usability and compliance. Are you using open source? Are you using paid or free tier tools? So that's really what determines the context in which you use to test. These factors will have an impact on many test related issues, including test strategy, test technique, or degree of test automation, required level of coverage, level of details of the test where test reporting, etc. Wow, it's too much. So I think we can stop here for today, then conclude this chapter one and tackle the MCQ. We we are stopping at the level of the test where we can continue with the test where tomorrow. Hi guys.
Ah,
Hello.
yes.
So I was saying that we'll continue from test where tomorrow because it's we have 4 minutes to time to the end of time, and I think we can continue from here tomorrow. Then from there we can answer all the chapter one MCQs all together. What's your take on this note? No one has a take, so I will say it's agreed. At what time can we meet tomorrow?
Fine.
9.
Yeah.
9 p.m. or a.m. and the time zone.
Bedtime.
Same time.
Yes.
Mm, same time. I'm not sure I'll be available.
Anyway, 9 p.m. is okay. 9 p.m. Eastern time.
9 p.m. Eastern time. What time is it in GMT?
I don't know, but now I have 5:57.
I think in GMT 2021.
21.
9 p.m. Eastern time is is 2 a.m. is 2 a.m. in GMT. That will be too late.
Mais she said 9 p.m. in Cameroon. I think she said 9 p.m. in Cameroon. Same as today.
Same time as today. I'm trying to say that I will not be available to tomorrow same time as
Ah,
today.
okay. Okay. But what
So we'll just throw a poll in the group. We'll throw a poll in the group. Kelly, you can stop the streaming. Kelly is still here. Okay, so let's call it a day. We'll throw a poll in the group to know when else we are meeting.
Okay, thank you.
You're welcome.
Thank you.